My name is Mac Rogers. I mentioned I work with Domino Data Lab. And forgive me, I've got a bit of a cold, so I will try to not cough too much. And if you can't hear me, just let me know, and I'll try to speak more into the mic. So the thing we're going to talk about today is reproducible dashboards in Jupyter and Domino. And so there's a few different ways we can take this, and I want to make sure that this is useful for you guys and it's useful for us. And so from out of everyone in the audience, what's the level of experience with Jupyter? Would you guys say you're sort of Jupyter curious and are interested in using it in the work that you guys do today? Or are you data scientists who use it heavily? Or so first group, interested, maybe it's useful, come to JupyterCon to learn more about what Jupyter is used for. A few people. And then like heavy Jupyter users who use it part of your data science day to day. Most of these tips and tricks will probably be things you already know. Good. And then is there anyone who's used Jupyter like in a more abnormal setting, like in terms of like making heavy extensions on it or modifications into how Jupyter works, or used as some flavor of a version that some companies like built things on top of? Okay, a little bit, good. That's good context for me. So as we jump in, brief introduction on myself. I have a degree in chemical engineering and then went to work for a quantitative hedge fund doing equities research. Not really related, and then now I work at Domino helping data scientists do more, better data science. Also not really related, so a bit all over the place, which has been exciting. One of the things that's really neat about Jupyter is that it's very related to not being related to things. So you can do lots of different things inside of a consistent kernel or inside of a consistent platform and really make great use of all the different tools, whatever you're accustomed to. So the things we want to talk about are both like tips and tricks about how to be like a little more efficient with Jupyter, so things you may not know of, but also how to make the best use of dashboards in your work, or what is a reproducible dashboard. So what does reproducibility mean in the context of a dashboard for the type of work that you're doing, whether it's looking at just like executing scripts or analyzing data or sharing your work. So let's see. Phil Guo with the ACM made this sort of like analysis of what is the data science lifecycle as part of his PhD dissertation. We at Domino really like this framework of how the data science process works. So if you ask a data scientist like you all, they'll say that like the amount of work that I spend actually doing data science is like 10 to 15% of my day. Most of the rest of it is spent either acquiring or cleaning data, designing experiments, or working with business leaders and figuring out how to make the work that they're doing impact their business, or just getting their code to run, which isn't really the exciting, sexy parts of data science. And so dashboards in this context are useful when you're analyzing the actual data that you're using. So like if you think about what is the goal of a dashboard, ultimately the thing that you want to do is synthesize some large amount of information, or like just some targeted amount of information in a way that conveys a point as concisely and succinctly as possible. And so this can either be like bringing together like very disparate data sources and showing some common theme or trend, or highlighting some unique occurrence inside of large data sets that this is relevant, or just like a regular ongoing update on something that you're familiar with. So I won't take credit for this life cycle, but if you think about how a dashboard is relevant here, it's going to fall into the realm of how you're disseminating the work that you've done. So how you're, when you think about what is relevant inside of a project, how you organize a dashboard is really relevant for what you think about what is important and how the people who are consuming your results are going to evaluate your thought process. It's also really useful for just like inspecting and exploring, and that's where Jupyter comes in hand. So I have a bit of a diverse background when it comes to applications of data science in different industries. So from my time in finance, one of the things that we're most concerned about when it comes to like reproducing the work that we've done is back testing. So if we have a trading strategy, how can we reproduce the results that it generated through this chunk of time in the future? We don't know what the landscape is going to look like. And how do we do it backwards through time to ensure that what we're seeing now is what is representative of the circumstances at that time. This is a little different from how reproducibility is thought about in insurance, for example, where one of the things that customers care a lot about is making sure that they can that they can convey to either an auditor or to a regulator that the reason we made this decision is because we had these principles or this thought about how this works. We put it into this model, and it produced that result then, and it produces that result now because there's no bias in what the decisions we're making. And then in the context of scientific research, this is a little different because the word reproducibility does actually have a distinct meaning, and it is distinct from repeatable as well as reproducible and replicable. And this is can be a little confusing because when I was in high school learning about science and how you design experiments, the distinction between replicable and reproducible is relatively easy to understand, though the actual terminology can be a little confusing. In the last few years, there have been papers that have sort of swapped the two. So if you start Googling around for what's the difference between reproducible versus replicable, there's a great blog by a UPenn professor that sort of outlines how people have bizarrely in the last 5 to 6 years started switching up the meaning to mean the one for the other. Where the key distinction is, repeatability is something that you can repeat. So if you run a function, it runs the same way this time as it does that time. Or if you measure the temperature of a solution, it is the same every time you measure it. Replicability traditionally is along the lines of if you see the results that someone has generated off of the same data using the same methodologies, can you come to the same conclusion? And that's along the lines of, does this individual, the person producing the results in the first place, have any inherent biases? So if you can do the exact same thing they do, can you come to the same conclusion? Reproducibility is a little different in that it's not just using the same information and tools that they use to draw the same conclusion, but to regenerate that information and come up with new methodologies of showing the same thing is true in both scenarios. And this is where, this is something that, at least at Domino, we think this is much more powerful because now you're not just proving that the conclusion that one person came to is reasonable or that it's true, but that the fundamental principles behind it are true. And so now you're coming up with, you get into the realm of what is the scientific method for coming up with truth. And if you can do that, come to the same conclusion from disparate ways, you can prove hey, this is actually real. Even if you use a different experiment with a different population, with a different methodology, the conclusion is the same and you're telling the same story, you now have a more convincing argument that this is the way things work. So that's a somewhat wordy explanation of the difference. But the point here is that reproducibility is more than just making sure that when you run something, it runs again the same way it did before. It's about leading the thought behind why it is the way it is. And so how do you do this in data science? Data science is a little tricky because you might be able to run the same notebook that you ran this morning in the afternoon, and it should hopefully produce the same results. But what if you try to run it on someone else's computer? Is it still going to produce the same results? Is there going to be a distinction between the version of one package that you're using versus the other computer? And is that actually going to materially change the conclusions that you draw from the work that you've done? Or does that mean that your entire conclusion is noise because a random outlier significantly changed the result that you drew? The way that we've seen reproducibility versus replicability work incredibly well in teams or organizations is the idea that you have to be able to do more than just replicate the versions of the code that you're running or the experiments that you're running or just the hardware that you're using. It's more than any one of those. It's the consolidated source of record or source of truth for the reasons why you're doing your work. So it's the combined GitHub plus Jira plus Confluence. All of those types of environments put together give you the ability to not just replicate the outcome of a calculation, but have a team generate consistent results and do it efficiently. So that's sort of what we think about when we consider reproducibility. It's more than just generating something again, but having a conversation that can happen through time. And so in the context of dashboards, most of this presentation consists of running or showing dashboards inside of Domino or Jupyter Dashboards in the context of Domino. Because at least as it is now, we don't really feel like it's possible to have a truly reproducible scientific process without something like Domino, or one of the other ways of doing this, powering it behind the scenes. So basically, I'm going to take a brief aside, sort of give some background context into what Domino is and how it works, so we can have some, basically a frame of reference when we start talking about the actual notebooks that we're going to work on. So Domino is, it's a combination of lots of different features which ultimately let you do the things that you're used to as a data scientist, but more efficiently. I'll jump back into the slides for 1 second to give you like the high-level overview of you can use the code, the tools, the data that you know and love. You don't have to relearn a new language. You don't have to learn a new IDE. I don't think we've updated this to include Jupyter Lab yet, but it does work. And inside of the context of, if you think of Domino as the connective mesh that binds all of these together, in the same way that you don't code in Jira and sales folks don't sell their product through Salesforce, but it is the system of record that lets you do work efficiently and collectively as an organization. You end up getting faster experimentation, you can collaborate more, you can audit the work of your peers and then also learn from it. So just the process of doing your work in a shared environment lets you share and compound best practices in a way that you can't get if you're working locally. And ultimately, you spend more time doing data science. So with that in mind, there are a few different things that we leverage inside of Domino to make like what we consider a truly reproducible dashboard. So I'm going to jump into my Jupyter Dashboard project. And the first thing I'm going to do is jump straight into the settings of this project. So I have some Jupyter Dashboards, or some Jupyter notebooks running in here that I'm treating as dashboards. But one of the things that's unique about this is that I can run these, any of these notebooks on whatever hardware tier provided by Amazon that I'd like with a drop down. So if I find that the work that I'm doing just isn't cutting it on my current machine, I can spin up to a massive like 2 terabyte X1 instance that can pretty much take whatever I can throw at it. Sure. There we go. And so with a simple drop-down, the same notebook that's running right now on a 2-core 8 GB machine can run on 128 cores with 2 terabytes of RAM, which is not crazy. But the other thing that we've abstracted away is, in addition to the hardware that goes along with the work that you're doing, also the compute environment that it runs in. So you could have like a specific point release of Jupyter, of Python, of R, of Numba, CUDA, any of like the specific packages that you want are pre-set up and configured in an environment that is also versioned. And so now you're in the realm of not just the environment that I'm working on now is the one that works, but the one that I was working on last week, the one that I was working on 6 months ago. I can see the history of how that came about, and I can see the provenance of how this was developed and the revisions that have been made. And if I need to, I can go back to an older version of this environment and know that my work will run as it did at that point in time. Lastly, we, so jumping back into the dashboard. So we've got a few tips and tricks for using dashboards in a way, just general for using dashboards. These are sort of the tips and tricks, which all of you Jupyter Power users may already be familiar with, so apologies if they're not that interesting. But the first is magics. You can use magics to basically bounce outside of the realm of what is normal inside of a notebook. While you can have different notebooks running different kernels, you can use R, Python, Scala, whatever you'd like. You can also do that directly inside of the notebook. So the easy way to use magics is to get the list of all of the magic commands that you have available with the %ls magic. Brief aside, if you want to have an entire cell run something differently, you can do 2% and it'll run in however you specify it. For example, what's that? Yeah. Sure. See if it'll work. Great, that better? Awesome. Yeah, sorry about that. Yeah, feel free to jump out. This is, or to shout out. This is interactive. And so one of the most useful ones that I found is time. And so you can time a specific line inside of your code. So it's going to tell you specifically how long this is taking and how long it took. And also time it. So you can actually break down a function that you're writing into specific chunks and start talking about and what time it's going to do is it's going to run it 1,000,000 times. And it's going to tell you which took longer, which took shorter. And also it's going to try and take a guess at how long, what's actually happening behind the scenes. So because one was substantially longer than the others, or than the fastest one, suggests that there's some caching going on, which is super helpful. And you see, like, as you start breaking this down, you can start to figure out where inside of your code things are going slowly or quickly to start optimizing. This one's pretty well known. If you have an exclamation point, it's going to basically run a bash command outside of the kernel. So you can see how recent your pandas is. But you can also do bash commands as the entire cell. So as I mentioned before, the double percents will let you change how an entire cell operates. So if you wanted your entire cell to run as a bash command, you can do that like this. But it also applies to something like LaTeX or HTML. And so you can have this entire cell operate as HTML, and the results will be rendered as such. Another popular use for another really convenient way that notebooks make it easy to do exploratory data work is that if you have a command at the end of a cell, it's going to automatically take a guess at how it should render it. So as opposed to in your Python terminal rendering columns and rows with dashes and lines, it's going to automatically render it with HTML. But I personally find this a little annoying because if I'm working with things I might want to see more than one thing rendered, I don't want a unique cell, but this can also be entirely customized using the interactive shell. So if I set this to render everything, I've got a nice list of whiskeys here and some different metadata about them. I can check out the head, tail, and the description all in one cell. All gets rendered nice. So there's some of the basic tips and tricks for making Jupyter a little more useful. With one more that I always like to show, I didn't know this until relatively recently actually, but if you hit Alt and select, you can get Sublime level multi-line editing. And that's something that is pretty useful. Yeah. Nice. Well, that's one of the basically Sublime hiding out inside of Jupyter. And so that's sort of like some ways that you can leverage the different functionality of Jupyter in order to be a little more efficient. One of the more interesting things is when you start getting into actually building dashboards. So remember, a dashboard we're thinking is like a way to synthesize information in order to tell a story in a way that you might not be able to do with just some written analysis or just a standard report. So I've got this batch demo. This is going to go scrape some earthquake data from the USGS and render an HTML map of earthquakes that have happened around the world in the last, I think, 24 hours. So that's pretty neat. Looks like something's going on down in Mexico. Poor Valparaiso is collapsing. And so we're importing some things. I've got this little toggle code button up here. And that's pretty useful because one thing that people really don't like about when using Jupyter notebooks as a way to disseminate information is that there's not a really easy way to hide all of the code that went into it. Like, no one really cares that you're importing pandas as PD, and no one really cares that much how you're looping through the JSON that's coming back. They just want to see this map. And so if we go ahead and run this, we've got a little toggle code button where we can turn the code on and off, but as soon as we click it, it goes away. And so what we're left with is all that we care about. And this alone is like somewhat useful because now we can hide the code and just highlight the things that is most interesting to us. This is sort of a hack around what the Jupyter Dashboards project is trying to overcome. And so we went ahead and installed that into our compute environment in Domino. So we can jump into the Jupyter Dashboards layout, which is in itself really useful. If we jump into the grid, we can see that the Jupyter Dashboards project is going to give us the ability to click and drag individual cells around to lay them out in a way that's useful for disseminating whatever information we care about. So I can move this block around, I can move this one. But because this is relatively simple, we don't have to do too much modifications. The downside of this, of course, is that the only way to view the results that you've generated in the Jupyter dashboard layout, unless you have a Jupyter dashboard server, is that you have to have someone have all of the right packages and extensions installed, and they have to have Jupyter dashboards running on their computer in order to see the format that you've set your notebook to. So by toggling the code with this little bit of HTML script, we now have something that can be converted to itself entirely HTML. And jumping back into the plugin Domino, if we run into the project itself, now we can start to use some of the other features that are really important for reproducibility in terms of dashboards. Like we can set up scheduled runs to go run this notebook automatically without having to convert it into a Python file, so that every morning it updates and we have a list of all of the recent earthquakes that have happened if that's something we're really interested in. So I can do a batch run of this batch notebook IPYNB. Which I have typoed. But I can also easily set this up to run on some schedule. So I've got this past one, which if I go into the details of what was run, I can schedule this to repeat at some regular cadence. And I can also email this around. So like say I have a report that I've got to generate, or I have a notebook that now I've taken the work to build out this notebook that explains my thoughts around this data set or what's happening in the world. And I've rearranged it in a way, I've hidden the code, I've got something nice and pretty. Now I can schedule this to repeat at a regular cadence with like incredible customization. And I can email this around. And when you do that, the thing that you're going to see is going to be a pre-rendered notebook that's going to look exactly like what we want, and that it's going to have the interactive dashboard that we can play around with and use, either delivered to your inbox via email or directly inside of a web browser. And in terms of how you use this with respect to reproducibility, if I jump into this specific run, I can say what's going on in Oklahoma after I dig into the actual map of the US and see where all these earthquakes are happening. And now I can like leave comments about exactly this version of this dashboard on this day. There was lots of stuff happening here. Rendered all, of course, in Markdown, so you can embed images, have fonts, all that sort of fun stuff. But again, to go back to the reproducibility, it's one thing to be able to show the result as it happened once, or to reproduce it again in the future, but to completely transfer that body of understanding that you've put into this work, one of the things you have to be able to do, in addition to sharing it, is the ability to go back in time and see how this has evolved. So I can actually go back and see, like, this is what the map looked like 3 hours ago when I last ran this. And I can have an entire discussion. But the notebook itself didn't have the code that we've added to collapse the cells. It is just the actual contents. And so this is a way to make the actual work that you're doing more than just one-off pieces of research, but like live artifacts that update over time and which others can build upon. So lastly, I wanted to show a slightly more complicated example of the Jupyter Dashboards project. So this is the default example that ships with Jupyter Dashboards. It's pretty cool. It's a Scotch recommendation engine. So I'm going to go ahead and run all these cells. And when it's complete, I'll be able to jump into a pre-configured dashboard layout where I pick a Scotch that I like. I prefer Macallan. I'll go with this one. And I can see what's similar based on an aggregate score, and then why it's different based on many different attributes of Scotch. But all this work lives in one place. It's been done once. It's been presented in a way that's easy to consume, so I can see exactly what the relevant bit of information is and take advantage of the work that's been done to organize it. So that's sort of the idea of reproducibility within dashboards and Domino. To not reiterate the point too hard, Domino is a place to do a lot of this type of work, scalable compute, we add the infrastructure around the work that you are already doing in order to make it reproducible. So going beyond just the ability to do something once on your computer or twice on your computer to the ability to do it on your colleague's computer or in groups collectively, to the ability to actually convey that information and be the system of record for the work your data science team is doing through time. And so lastly, before I finish up, I did want to show off something that we've been working on in tandem with the Jupyter Labs group. And I know there's been a lot of talk of Jupyter Labs today, but this is one of the more exciting things that I've been learning about at JupyterCon, but just the basic functionality of Jupyter Labs. And again, a bit of a shameless plug for Domino. This is all like default out of the box how Jupyter Labs works, but we're able to run it inside of our environments because they're incredibly extensible. So all the cool things that you get with Jupyter Labs, the ability to look at a directory of all of your files, see what's running, run commands, sell toolbars, as well as pop open new sessions. Can all be done inside of a Domino-like environment using Jupyter Lab functionality, which is pretty cool. All right, so in the context of reproducible dashboards, Domino, Jupyter Lab, any questions? Great. Well, thanks a bunch, guys. I'm happy to stick around and talk more about Jupyter Dashboards, anything else. Anything else you want to talk about? Question? Yeah, so these are publicly available. I don't know if we've posted them yet, but we will send them out through O'Reilly. These are all public Domino projects. So what that means is you can jump into this project as anyone on the web. You can jump in, you can spin up your own notebook, and you can start clicking around and playing with it. These will be, we'll post some links somewhere. These are hosted on our cloud environment. So theory, you would need to sign up for an account and like buy a license, but because of this, they will be open and freely available. So as long as you go to the link, I believe it's app.dominodatalab.com. It's where they'll be hosted, and then it's a very long, ugly URL to get to them specifically, but I'll share that with y'all. No, you can download them and run them locally. So they're hosted there, and that's how you can access them. But from there, you can download them and run them on your local computer.
What were you saying about whether people will see the layout?
I'm not sure.
You said something about, if I download it, will I see the layout?
Oh, yeah. So if you have the Jupyter Dashboards extension installed, which is basically these, you'll be able to see the notebook arranged in the way that whoever designed the notebook prearranged them as a dashboard.
So is the Jupyter Dashboards extension a project?
No, it's a project from Jupyter. Yeah, they've been working on it for like a year and a half, maybe. It's not incredibly well known, but it's pretty useful. Yeah, you basically build a Jupyter dashboard and then like start clicking and dragging things around. It's really cool.
Right now, with that work in GitHub or GitHub?
I don't believe it renders in GitHub because you have to open the notebook and then tell it to run the cells. So it's not just in the same way that GitHub renders a Jupyter notebook. You have to actually activate the notebook extension. We played around with it because like ideally we'd want to have like a URL you can just share and like here's a notebook in a dashboard format. But it's not there yet. If we were to figure out how the Jupyter Dashboards project is going, yes. We actually have a whole like area of our product around app publishing, so making like Flask or Shiny apps publicly available without having to like spin up a server. But in terms of like, we try not to heavily modify open source software unless we're like contributing to the body of work, just because we don't like some Domino custom version of Jupyter or something like that. To Jupyter in general or within Domino? Yeah, so there's an entire collection of third-party extensions for using the magics. One I think that I've seen before is pastebin. You can do like %% pastebin variable, and it'll get instantly put on pastebin, and you can develop these yourself. They're pretty cool. All right. Thanks.